Hi, this is Nathan Melcher for demonstration 1 on calculus 3A. So for question 1, it asked to take a problem off exam 1 that you didn't get full credit on and to rewrite it. So I did question 4 in exam 1. So for part A, it asked to find the limit of this equation here. So you divide by the highest denominator power, which in this case would be x to the 4th. So when you divide everything by x to the 4th, you end up getting this right here. And then what you do with that is you can take the limit of the top and the limit of the bottom. And as x goes to infinity, a limit when you plug in for x in the denominator is just going to disappear. It's going to equal 0. So what you're left with is 7 divided by -1. And then for part B, you have a limit of x goes to infinity of sine of arctan of x plus 1 over x. So what you're going to do with that is limit of sine of arctan of x go plus limit of 1 over x. Now the limit of 1 over x is 0. Once again, because the x is in the denominator, it's going to cancel out and become 0. The arctan here is going to go to pi over 2. And then what you end up doing with that is since sine is continuous and limit of x is equal to, or x goes to infinity, it's going to be 1. So you end up with 1 plus 0 is equal to 1. Then for question 2, all right, sorry about that. So for question 2 here, we have, it asks us to find the, use the squeeze theorem to compute the limit of 3. Let me write that down. So we want to use the, let me add a new page. All right, so we're just going to use the squeeze theorem to compute as x goes to 3 on the right, so x goes to 3 positive is x minus 3 of f of x. So what I did here is I wrote, this is what we're looking at in the middle here. And then what I did is I just wrote the two equations here on the side, x. So I didn't mean to erase that. That goes over there. Then what you can do is simplify this bottom out to x plus 1 and x minus 3, cancel out the x minus 3. Same thing over here. Bottom can go to 4x plus 3, cancel out the x plus 3's. So over here, you're left with x over x plus 1 is less than or equal to x minus 3 times f of x is less than or equal to 3/4 times 4 to the x minus 3. Then you have your g of x and your h of x. And what the squeeze theorem states is that if g of x is less than or equal to f of x and h of x is greater than or equal to f of x, then your limit is equal to f of x. So since each side over here, when we plug in 3 to both of these, we have 3. You have 3 over 3 plus 1 is equal to 3/4, and you have 3/4 times 4 to the 4 minus 3, which is 4 to the first. So 4 to the 1 is 0. Oh, I did that backwards. This should be a 3 here. 3 minus 3, which is 0, and 4 to the 0 is 0. Is 1. I'm sorry. 4 to the 0 is 1. Completely messed that up. 4 to the 0 is equal to 1. So then you have 3/4 times 4 to the 0, which is equal to 1. So you end up with 3/4 is equal to f of x, which is less than or equal to 3/4. So your limit as x goes to 3 from the right hand side is f of x is 3/4, since the squeeze theorem is true. Now we're moving on to question 3, which gives you this piecewise function of x plus 1 if x is less than 2, and 1/2 times x minus 1 squared plus 5 over 2 if x is greater than or equal to 2. So you have to check the conditions for part A, which f of a is defined. So when we're looking for 2, if f of 2 is true, you would use the second equation. Since it's greater than or equal to, we're using that equal to. So you were able to put this in, you get 3. So that means defined it was true. Then the limit of f of x exists, means that the limit from the left-hand side and the limit from the right-hand side are equal to each other, meaning they exist. So if we plug it in for the first equation, 2 minus is 2 plus 1, because x plus 1, 2 plus 1 is equal to 3. We did this equation right here, which is the second part. So we can just pull that down of 2 plus, which is equal to 3. And since they are equal to each other, that means it's continuous, which satisfies the third condition. So now if we go down here of limit of x approaches 0. So what you do here for the limit is anywhere that there is the basic limit formula is limit as h goes to 0 of a plus, you have f of a plus h minus f of a over h. So what you do is anywhere that there's an x in the f of a, you're going to plug in a plus h for the first part and a for the second part. So since this is 0 here, what you're going to do is you use that first equation of x plus 1. So what you do is x plus 1, so you have a plus h plus 1 minus x plus 1 or a plus 1 over h. Then since this, you have to make sure this this multiply sign or the minus sign here gets distributed to the minus a and the minus 1. So you have a minus a cancels, 1 minus 1 cancels. You're left with h over h, which is equal to 1. So the limit of h minus 0 is equal to 1. Yes, so that means that f of a is equal, f prime of a is equal to 1 when a is less than 2. Then next we're asked to compute the limit of the second part when you compute the limit of f prime of a when a is greater than 2. So then since it's part C is when it's greater than 2. So what we're going to do there is we're going to use the second formula since it's greater than 2. So same thing everywhere there's an x, you're going to plug in an a. So what we do is when you plug in that a plus h, so you plug them in, cancel everything out that you need to here. This is important here. You split up this minus sign here. You have to make sure to distribute to this entire second half. So I just split it up so you could visually see that this minus goes to this entire second half of the equation. So then you cancel everything out from that. You end up getting 1/2 h squared plus ah minus h over h. So you can pull an h out of that right here. And you get limit as h goes to 0 is h times 1/2 h plus a minus 1 over h. So you can get rid of the h, divide. Then you plug in the 0 for h there. So then the 1/2 times 0 is equal to 0. Then that goes away and you're left with a plus 1. So you're left with f prime of a if x is greater than 2 is equal to a minus 1. Then for part D, we're asked to compute a two-sided limit, so from the left side and from the right side. So we start with the right side here. So this is the greater than 2 part. So we use that second equation, greater than 2, cancel everything out as we continue to go down here. We're still on the greater than 2, and as we continue to cancel everything out, greater than 2. So we're using 0 plus. Then when you get down here, you plug in 0 and you get 1. So for f prime of 2, excuse me, that's not supposed to be f prime, that's just supposed to be f of 2 is equal to 1. And then as you move down here, part E, same thing, but except we're going to use this minus sign right here on the 0, which means we're coming from the left side. So as you come down here, and then you end up just canceling this out because it's x plus 1, so you plug in h and a for all of that. You end up with h over h was equal to 1. And then part F, as we move down, is did they equal the same number? Yes, they both were equal to 1. And what does that mean? That means that the derivative is at 2. F is differentiable at 2. So what that means is we take the equations, their answers that we got. So when we went f minus on the left side of 2, we got 1. So then that first equation gets replaced with 1, 1. So f prime of a is going to equal 1 if x is less than 2. Then when we came from the right-hand side, we got, if we come up here and we come from the right-hand side, we got a minus 1 right here, a minus 1. So then we scroll down here. And as you come from the right-hand side, so anything greater than or equal to 2, it's going to be x minus 1. And that is it for demonstration 1. Thank you.